big as I want it to, it never stops, never gets close to any fixed value. Okay? All right. Now, behavior like this is sort of behavior where our function grows without bound around a single x value. That's indicative of something, typically, some sort of rules of mathematics are trying to be violated there. Okay? The reason that we get this behavior here where one side goes off to positive infinity, the other side goes off to negative infinity, why does that happen right here around x equals 0? Well, I can't use x equals 0 as a value, right? Why can't I use x equals 0 as a value? Right, because around this place, I'm trying to divide by 0. Right? That's what's going on here, is that I'm getting closer and closer to this line x equals 0. I'm trying to get closer and closer to things in the denominator that look like 0, and I'm not allowed to divide by 0. Division by 0 is not allowed. And so that's what's sort of causing this behavior right here, is that I'm trying to violate some laws of math. And when you try to violate laws of math, things go bad. Okay? And so that's where I'm getting this bad behavior here. Now,
is that where the math police come in?
the math police will come later if you're bad. Only if you actually did divide by 0 will they show up.
Do they come on bikes or in cars?
I think they have a helicopter.
Okay.
They land out on the football field and all that stuff is underneath.
So they're sponsored by Bill Gates then? Or?
It's Larry Ellison. Larry Ellison. He's a different guy. Him and Bill Gates are friends. All right. No, not really. This behavior where we get close to this vertical line here, we shoot off to infinity or minus infinity. That's indicative of what is called a vertical asymptote. Okay? A vertical asymptote is a line x equals c where the limit as x approaches c from either the left or the right results in our function having a limit equal to plus or minus infinity. Okay. Now, you've seen vertical asymptotes a lot in your previous work probably, because they say that vertical asymptotes occur whenever you try to do what? Well, what did we just try to do here? We try to divide by 0. Vertical asymptotes will oftentimes show up when you try to divide by 0. Not always, but sometimes. Look at some examples here. Consider the following functions. X minus 2 quantity squared divided by x squared minus 4. X minus 3 over x squared minus 4. Well, that's x. 2x. H of x. Last one. 2 minus x over x minus 2. Alright, so let's take a look at these and study a little more. Alright. 4 x minus 2 over the quantity x squared minus 4. Okay, alright, now if you look at each of these functions, each of these functions we can again sort of consider them and look for asymptotes of these functions. That's what I'd like to do. I'd like to identify all possible asymptotes for these functions that we have listed here. That includes horizontal asymptotes, vertical asymptotes, and oblique asymptotes if there are any. Okay? So, what we're going to do is we're going to look at finding all asymptotes. Okay. Well, the final asymptotes. So that means I'm going to look at a bunch of limits. Okay. So I'm going to start with my horizontal asymptotes. Horizontal asymptotes mean I have to look at what kind of limit? Horizontal asymptotes involve looking at the limit as x goes to infinity or minus infinity of our function. So for the first one, the limit as x goes to infinity of f of x. Okay. All right, well, if we look at this function, what can we do? I have x minus 2 squared over x squared minus 4. Okay, I can factor it if I want. Let's see if that's what we choose to go with. What do we get? So the bottom is what? Plus 2. Okay, x plus 2 times x minus 2. If we do that, let's see, I can make some cancellations here. I now look at the limit as x goes to infinity of my x minus 2 over x plus 2. Okay, what happens to that function? As I plug in very, very large values of x, what's going on here? What's this limit equal to? Not 0. This function should be getting closer and closer to value 1. Remember, there's a couple of different tools we have to evaluate them. One thing we can do is we can, like we did at the beginning of class, we can factor an x out of the top and one out of the bottom, do the cancellation, and then look at what happens. The other one is that this is a polynomial, this is a polynomial. Just divide their leading coefficients. Provided they both have the same degree, we can just divide their leading coefficients, and we'll end up with 1 there. Okay? All right, good. So we found the horizontal asymptote here. Okay? What about oblique asymptotes? Does this function have any oblique asymptotes? Why not?
The degree isn't greater.
What's that?
The degree in the numerator isn't 1 greater than
The degree of the denominator?
yeah.
Right. So in this particular problem, there's not going to be an oblique asymptote because the degree of the top is equal to the degree of the bottom. Okay? So there's no oblique asymptote for this one. All right. And then finally, we can ask about vertical asymptotes. Vertical asymptotes are places where our values, they're x values, for which when we get close to those x values, we have troubles with our graph. Based on what we've done so far, where do you think the vertical asymptotes of this function might occur at? Well, let's see. We look at our function here, and we say, okay, we simplified our function a little bit over here, right? We saw that we could simplify that function we started with, f of x, down into x minus 2 over x plus 2. All right, now, if you look at this function, you say, okay, where could bad things happen with this function? The bad things with this function are going to happen around x equals negative 2, right? Because what I'm ending up doing is I'm ending up plugging in very, very small values in the denominator. And I'm getting values very, very close to minus 4 in the numerator. Well, let's see. Minus 4 divided by things that are very small is going to cause it to get very big. Okay? So our guess right now is that we need to look at what happens around x equals minus 2. Okay? So let's take a look at that limit. Limit as x gets close to 2 from the left of f of x. Well, let's see. I'm approaching 2 from the left. Okay, so I'm coming in this way. It's actually negative 2. Sorry. Negative 2 from the left. All right. So values that are approaching negative 2 from the left are just a little bit bigger than negative 2. Or sorry. They're just a little bit smaller than negative 2. They're further in the negative direction than negative 2 is. Okay? All right. When I plug in values that are just less than negative 2 into the denominator, okay? So that, like for example, negative 2.1. Okay? What's the value of the denominator? At negative 2.1, the value of the denominator would be negative 0.1. Value in the top, let's see. negative 2.1 minus 2 is going to be negative 4.1. And so as I move in from the left, what I'm getting is negative on the top divided by a negative on the bottom, a negative divided by a negative, positive, okay? The value in the bottom is very, very small though, so the values that I get out here are going off to a positive infinity, okay? So as I come in from the left, I get this shooting off to positive infinity, okay? That's one of the conditions we need to look for our vertical asymptotes. We can do the same thing in the other side, limit as x approaches negative 2 from the right of f of x. Okay? And we're going to do the same thing. I'm going to sort of look at what happens as I'm getting closer to negative 2 from numbers that are just a little bit bigger than it. Well, again, numbers just bigger than negative 2 in the top would be something like negative 1.9. Well, negative 1.9 minus 2 is negative. That's all I care about. Negative still. Okay. 1.9 in the bottom, negative 1.9 in the bottom. The difference here is going to be, well, it's going to be a positive value, right? Something slightly bigger than negative 2 plus 2 is going to result in a positive number. So here, on this side, I have a negative value divided by a very, very, very small positive value. What's happening to that? It's getting very, very large in the negative sense. And in fact, that limit is going off to negative infinity. Okay? So here we see that around x equals minus 2, we do have this behavior. Our function is going off to infinities on either side of the value negative 2. So, in this case, x equals negative 2 is a vertical asymptote. For most rational functions like this, for most of these fraction type functions that we're dealing with here, okay, vertical asymptotes are going to occur at places where we're trying to divide by 0 in the denominator. Okay? Whenever we're trying to divide by 0, those are the values we need to check to see if there are vertical asymptotes there. Okay? Let's take a look at number 3 real quick. And we'll do the horizontal asymptote there first. We take a limit as x goes to infinity of h of x. This one here. What happens in this case with this function? As we get closer and closer to infinity, right, larger and larger values of x, what goes on here? This gets closer and closer to what? Yes. Okay. So it should be 0. Okay. One way of checking that again, the degree of the top is smaller than the degree of the bottom, which means that the bottom is growing a lot faster than the top is. The top is not getting a chance to catch up. Okay. The bottom is getting so big so fast, all of our values are getting closer and closer to 0. Okay. What about our vertical asymptotes? Does this have any vertical asymptotes? Well, where should I check? Okay. I should check to see if x equals 2 is a bad spot. So let's take a look at x equals 2. We'll take our limit on both sides of 2. So 2 from the left, limit as x approaches 2 from the right. Okay. Let's see. If we approach 2 from the left, see what do we have? 2 minus x over 1x minus 2 cubed. Let's see. As I get values of x that are very, very, very close to 2, but slightly bigger, slightly smaller. Okay. Slightly smaller than 2 on the top is going to result in what? Positive or negative? Positive. Slightly smaller than 2 on the top is going to give us a positive value. Alright? Now how about the denominator? Slightly smaller than 2. Slightly smaller than 2 in the bottom here is going to result in a negative. So in this case, this limit, as we're getting closer and closer to negative 2, is getting closer and closer to negative infinity. All right, what about the bottom one? Okay, we have 2 minus x over x minus 2 cubed. Here I'm looking at values just a little bit bigger than 2.